Hello, this is Scotty with Xandercat LLC, bringing you part 2 of exploring baked lighting in Unity. I'm not a baked lighting or Unity expert per se, so this is more of a learning exercise to see what kind of trouble you can run into with baked lighting, to try to come up with solutions for doing baked lighting, and to anyone who is an expert with baked lighting or who has other experiences or other tips or tricks they would like to share, please do. Um, Otherwise, you can follow along and maybe you'll learn a thing or two as we go through this with me. So at the end of the last video, we had finished on this particular concrete room. This is a sort of a modular room built with 4 meter by 4 meter panels. It's an 8 meter by 8 meter room, so we've got 4 panels on the roof and ceiling with 2 on each wall. In some cases, we have some extra little trim pieces. A couple of props in the room. We finished this with 2 sets of lights. There's an overall ambient area light in the room to provide just sort of the ambient overall room light, and that is a rectangular area light, and there's actually 2 of them, one facing in each direction, one facing up, one facing down. And then we also added sort of an accent light over here. You can't pretend you have like a lamp on top of this barrel, producing a little bit of a wider light, and this one's using a disc. And in this case, we have a disc facing down and a disc facing up, which produces a little bit of a dark band on the wall. The overall lighting of the room looks pretty good. This time we're going to explore some new issues, and we're also going to switch to a wall texture that is more plain, more like a painted wall, that's lighter in color. By using a light just fixed color that tends to expose issues the best. And we want to see those issues while we're doing this exercise. So a quick touch on what's the goal of what we're doing. The goal is to come up with an overall methodology for building interior sets with interior lighting that you can follow and have generally consistent results, and allow you to build sets efficiently. Xandercat is a very small indie studio. We have no full-time employees. It's really just sort of a free time project, and there's no funding source, external funding source. So in order to build a game that is of sufficient quality that we can finish in a reasonable time frame, we need to make sure we are building out the game as efficiently as we possibly can. So the goal is to come up with an efficient means for setting up all of our interior sets and lighting within the game. Now, one of the ways I would like to do that as sort of the chief developer on the team is using a modular building approach, using sort of a standard 4 meter by 4 meter tile that's used for floors and walls, and then adding trim pieces on top of those as needed to be able to build out sets just using a set of tiles with a modular approach, kind of like building, a house model out of Legos, as opposed to trying to, say, print a model with a 3D printer. For me, it's more efficient to be able to build out of Legos, or in this case, out of a modular approach to the interior sets, just because of how easy it is to to adjust those interior rooms as needed as you're building out the sets. So you might find you need to make room a little bit bigger or a little bit smaller, maybe change the roof to be a little higher or lower. And for me, it's a lot more efficient to be able to use this modular approach to just change the tile configuration as opposed to having to go back to Blender, modify the models, re-export the models, move the models, replace the models in the game engine. And to me, that's just a lot more work than just reconfiguring the modular layout of the panels. So that's why I'm going with this sort of modular approach. But this modular approach also does have additional issues with things such as baked lighting, and we'll see some of that as we continue on. So let's continue on to the next room. This room looked pretty good with the exception of that kind of dark band where the disc lights are. But there are some issues that are not apparent. So let's fly over to the next room. And here we have, we've switched to the sort of fixed color wall, and we've used that same tile on the roof and on the floor as well. We've added some trim at a door, which it's not really important to what we're doing today, but now this wall texture does have just a little bit of texture if you get in close to look kind of like a brushed or rolled on paint on the wall, but overall it's just a consistent color, which allows us to see issues more easily with the lighting. And you can see that here. This is the same lighting as the previous room, but now you can see when we have a less busy texture, there is some what looks like sort of a pinched effect going on at the edge of those area lights, ambient area lights. There's a little bit of a brighter band right at that edge. It's not too bad, but you can see it. And we also now see some new issues cropping up. If we look at the floor, you can see this dark line here, what's going on there. Same issue, you can see it a little better now though with the dark edge where the disc is for that accent light. And you might think, well, is this just a tile position issue? It's not. This is a baked lighting issue, and you can tell that by just using a real-time light to sort of overpower the baked lighting a bit. And if you get down there close to it, you can tell this more on some of the other rooms, but these panels are actually right next to each other the way they're supposed to be. This is actually just a baked lighting issue. But we'll get more into that in the later rooms. The first thing we were wanting to look at is how else we could set up the area lights to maybe try to mitigate some of the issues with that we currently have with this sort of two area light approach. You could, I discussed in the previous video, you could rotate this a little bit to try to make the lines over on these other two walls, and that might be where you wouldn't really notice it, and that might be sufficient. But I was going to explore some other solutions as well. The first one was to try an approach where, what if you had, instead of just two of these area lights, what if you made them overall smaller, almost more like a simulated point light? Instead of having two of them, let's have 6 so that they're on each axis. So let's take a look at that in the next room. And I've set the intensity lower here, probably a little too low, but we can still take a look at it. So here, if we look at it, you'll see I've made the area light smaller in size, intensity is less, and there are now 6 of them facing down each axis. Now it's hard to say what the ideal size would be if you were going to use this type of approach, but it does get rid of that pinched light effect in the corners. I've done the same thing with the disc light here. There are now 6 of them. I made the disc smaller, and now there's 6. And if we just, let me briefly turn off gizmos. You can, if you look hard, you can still see where the intersections of the discs are. There's a very slight darker band here, and also here up and down. You can see that on the ceiling as well, but it's really minor now. So this, it looks better. Is it the approach to go with? I don't know, but this does provide at least a better look than the previous one did. So let's turn those gizmos back on. You will see, though, an additional anomaly in this particular room. What's going on with this circle here? That's interesting. And if we look around at the other walls, we don't really see that on any other wall. So let's take a closer look at the individual discs, and just to see what they're doing. Most of them are have a range where they're going pretty far, a lot further than where the wall is. This one's interesting because it gets kind of close to the wall but stops short of it. And the one we're particularly interested in is this one. Why is it creating this circle on the wall? If we take a look at the range on it, it's extending to the wall and just slightly through that wall, just a very small amount. So that makes it somewhat suspect. Is this a sort of an absolute distance problem where at certain distances you'll get this effect? Or could this be a relative distance problem where the problem is just the fact that it's hitting the wall right near the extent of the range? And we'll take a look at that in the next room. So here we're playing just primarily with that disc, although I've made a longer room so I can play with some different disc configurations. And we'll take a look at those. Here's the original one just to show it again in this new room. You can kind of ignore the these area lights. I was just doing some copying and needed a little bit of ambient light in here, so we'll ignore those, but we're finally just interested in these discs right now. So here we have that same configuration as before that has a circle. What did I do different on this one? This one I made it just the range a little bit less, so it stops just short of the wall. Interesting result. You still have a circle, but it's smaller. Alright. Let's see what I did here. This time I made the range a lot longer to extend through the wall, a longer range. And you can see there's no circle here. So whatever's going on, the circle is gone. If it is adding light to the wall, and presumably it is, it's got a gradient now, like you would kind of expect. Similar thing with the next 3 setups. Here's one where we just physically put it a lot closer to the wall with a longer range, and you have kind of the gradient you would expect with the light. Looks pretty good for what it is. Here's the same light just a little bit further back. Again, a nice gradient effect. A little bit of a hard edge where the disc is, but that's to be expected. And here again, the same one again. Still extending a ways through the wall. Looks fine. So it would appear that this particular issue is specific to having a range on the area light that terminates very close to something that is being lit by the baked lighting. I think you can think of this as like having this dome over the end of the range where the light stops. And that's why you would have a smaller one here, even though that line doesn't even reach the wall. If there's like a dome effect actually happening here, that would explain why you have a small circle here and a larger circle here. And I think in that case, what you need to do is just make sure that your range is set so that it doesn't terminate real close to something it's going to be casting light on. So that's something I didn't know before, but seems to be the case based off of what we're seeing here. Once again, we have some color anomalies going on. At the seams. Where was one? I was wanting to look at one in particular. Might have been in the first room. Let's go back over to that one. Here's a slightly different effect that you might see where you have almost like some red and maybe bluish spots at the seam as well, in addition to the black line. Now I've heard that can be sometimes a compression issue. If you look over at light map compression, I've got it set on high quality. If you want to play with that, it's possible that could fix some of those types of anomalies if you have them. Here we have like an automatic light map compression. You can actually do more than just change between these values. If I were to look at this particular panel under light mapping, you can find the baked light map, and then if we click on that and bring up the inspector for it, you will see it has a format of automatic, compression high quality. You can actually change this format and you can play around with some different compressions formats, and some of those might give you results that work better. But that's something you can maybe play with if you have these types of coloration issues. I don't know if that'll fix it for you necessarily, but it's another thing you can play with. Let me go back in here. Another thing to be aware of is as I was looking to address these dark bands along some of the seams, I discovered that there's actually a second UV map on meshes that you can have. And the first one is the one you typically are more aware of, that deals with how your textures are laid out on your meshes. And we'll briefly go and take a look at Blender to see an example of that. I'm on the UV editing, and you can see here's a UV map for this basic wall panel that I've got. And this is the UV map over here. When you set this up, this affects how your texture lays out on the faces of your mesh. Now it's at times advantageous to have the individual faces right next to each other on the UV map. If you have like a pattern in your texture that you're going to put on it, you generally want that texture to continue across neighboring faces. And what works really well for setting up this UV map is to You know, select all for your model. Go to UV, unwrap, and there is this Smart UV Project in Blender. It does a pretty good job. You might still have to manually edit sometimes, depending on what it does, but this usually gives you a great starting spot for how your UVs are set up. But getting back to the lighting, there is actually a second UV map you can have, and if I just briefly go back to Unity, and if we were to look at one of the imported models, let me get to one real quick. Let's just actually just go here and find that prefab. And now I'm looking at the individual mesh when it was imported over here on the right. You will note this Generate Light Map UVs checkbox. Generate light map UVs into UV2. Now if you check that, it will automatically try to generate your light map UVs, and that's gonna be for how your baked lighting lights the mesh. Now if you don't have that checked, I would guess what it's doing is just using your one UV map you've got for lighting in addition to just the texture layout. If you check this, then it'll try to generate a separate, I think, light map UV, and you might find that works for you. I tried it and wasn't entirely happy with what I was seeing, so I decided to see if I could actually create a UV map for lighting in Blender. So let's go back to Blender, and it appears all you have to do for that is you go to this data tab and you can click this plus to add a second UV map. So I did that, and I've got this UV map 001 that was added, and then making sure I had it selected over here and here. I then did another UV unwrap with the Smart UV Project. For this one, however, I went into this island margin and gave it like a 0.1 margin. So what that did is it put space between the faces. And the idea here was the reason we have that dark edge is probably because the lighting, there's an area in the light map for these individual edge faces, and those are going to be black because the light can't reach them. But that black, you might be seeing that right on the edge of the face that does have light. You know, if the light map doesn't perfectly transition between the two. So can we fix that by just, for lighting specifically, moving the faces apart a little bit and giving them an island margin? So I've done that on these last two rooms. I re-exported this wall panel with this particular UV map as a second UV. Going back into Blender, let's go out and take a look. And I only did this on the floor initially, and I did it in two rooms just for to have two samples. And this is sort of a copy of the very first room, but with updated floor tiles. And if we take a look now at the floor, so no black lines on this one. You can see a little bit of more of a lighter color line here, but it's pretty subtle. I think generally this you can get away with in most cases, especially on a floor, because most floors are probably going to be have more texture to them, like either a wood floor or maybe you've got like a marble floor or something. And this is subtle enough that even if it's a little bit brighter edge for whatever reason, as long as it's consistent, you're probably not even going to notice it. So I'm even though I'd like to see absolutely no edge at all, I think this is sufficient for development. And then let's just take another look at a second room. Try to make sure that that first one wasn't just an anomaly where it just came out looking right even though it wasn't. But this one looks good too. So I think that actually fixes the dark seam issue. So I think that solves that particular issue. So that's all I have for this particular video today. Maybe I'll do a third one, depending on if I learn enough new stuff that it's worth bringing you a third video in this series. But with each one of these, I think we're getting closer to knowing how we can set up all of our panels for the floors and walls and ceilings with a modular construction approach, and how to set up our area lights. I'm going to go back to the lighting tab just briefly, just to show you a couple of other settings there to be aware of. There's additional things you can do that can improve the lighting, such as adjusting these samples, direct samples, indirect samples, environment samples. There's the number of bounces. Most of these I have set to default, just what was default when you first set up the lighting. I might have increased the max light map size a little bit from default, but I'm still mostly working with default values. For those seams, another thing we can play with, which I didn't do in this video, is this light map padding. That maybe can have some effect. That sets the separation in texels between shapes and the baked light map. I'm not sure in which cases that will help, but that's something else that just to be thinking about that might have some effect in some of these cases. A couple other quick notes. If you're just doing light mapping or baked lighting for the first time, when I first set this up, the default was progressive CPU. In almost all cases, unless you've got a really terrible GPU, you want to change that to progressive GPU. In my case, I saw basically a full order of magnitude difference, to about 10x difference. When I first did a progressive CPU bake, it took about 45 minutes. When I switched it to the progressive GPU, it was only about 4 minutes. Huge difference. So if you can use progressive GPU, I recommend you do that, because you can save a ton of time on your bakes. Now that's with fairly modern hardware, not top end, but pretty decent. I've got a 13600K Intel i5 CPU, and a AMD Radeon RX 7800 XT GPU. So with that combination, the light mapper for using the GPU is 10 times faster than CPU. There's some other settings that greatly affect bake time, like the light map resolution. Some of these values you might want to increase for like your finished product, but you'll want to decrease them for just during development, so it doesn't take forever to do your bakes whenever you tweak a light setting. Or if you tweak an area light and you want to see the result, you don't want your bake to take an hour. But like this light map resolution, if you were to say, as just an example, I tried bumping it up from 40 to 100, and that actually increased the bake time by a factor of 6. So it took like six times longer at a light map resolution of 100 compared to 40. So you probably want to keep that relatively low during development. Only bump it up if you just want to see if it fixes a problem, or if it doesn't enhance the appearance and make it look better. Probably only do that as like a part of your deployment process when right before you do a build. Bump that up, do a bake, and then when you're going to go back to development, bump it back down. That's all I have for today. Thanks for watching, and we'll see you next time.